Today's goal is to factor quadratic expressions where the leading coefficient is not 1. Keep in mind, factor means we're going to divide or write as a product. Quadratic expressions are expressions in the form ax squared plus bx plus c. And when we say the leading coefficient is not 1, we mean we're looking at this term a. So far, we've been factoring expressions like example 1, where the leading coefficient is an unwritten 1. And to do that, we found two numbers that multiplied to positive 14 and added up to negative 9. And we just rewrote as a product of factors using the numbers we came up with that fit this description. But when the leading coefficient is not 1, like in example 2, you can either use the big X method and factor by grouping. If you want to do that, see your classwork packet. You are welcome to do so. Or you can guess and check. Let me show you what I mean. I'm going to write out two sets of parentheses for my two factors, and I'm first thinking about this 2x squared term. To get 2x squared, I'm going to multiply 2x times 1x. And then I'm thinking about the positive 30. Well, to get positive 30, you could try maybe 2 and 15. And positive, also I'll fill in both positive signs. Well, if I use the box method to check, 2x plus 2 times x plus 15, indeed, I get that 2x squared term. Indeed, I get the 30 term that I designed. But I would get 2x plus 30x is 32x. So when I combine my like terms, I'm not getting this plus 17x that I want. So I got to try something else. Okay, let's try 2x and x again to get my 2x squared term. Now let's try 6 times 5 gives me 30. Let's check it. See if we got it. 2x plus 6 times x plus 5. Again, I get the 2x squared and the 30 by design, so I really need to check this middle term. But 6x plus 10x, that doesn't give me 17x. Here is where this factoring strategy is a little bit different when the leading coefficient, the number in front of x squared, isn't 1. If I switch the order of the terms, meaning I keep 2x and x where they are, but this time I try 5 and 6 here. I've switched around their order. That's going to affect my results of the middle term. Here I'd get 5x, here I'd get 12x, and we know that 5x and 12x add up to 17x. We got 2x squared and 30 by design, so we're really just checking this middle term. By guessing and checking until we find the right combination of numbers, 2 and 15 were never going to work, but I should have tried flipping if I thought that might be better. So the right combination of numbers and also the right order. Let's try one more. We'll factor the expression 6x squared minus 5x minus 4. To get 6x squared, maybe I'm going to try 6x and x. Oops, to get negative 4, I'm going to try, I don't know, maybe a positive 4 and a negative 1. Again, I know I'm getting negative 4 by design. I know I'm getting 6x squared by multiplying 6x times x. So I'm just checking these middle terms. I would get 4x and I would get negative 6x. But those add up to negative 2x, not this negative 5x. Okay, let's try something else. Maybe I'm going to try 6x and x again. Maybe this time I'm going to try a positive 1 and a negative 4 here. I'm switching the order of the 1 and the 4. Let's check it out. I would get x here. I would get negative 24x. That doesn't work. Okay, let's try something else. Well, to get 6x, I could try 2x times 3x. I'm going to try some different numbers. To get that negative 4, maybe it's positive 2 and negative 2. I'm switching all kinds of numbers around. Here, if I multiply these terms, I get 6x. If I multiply these terms, I get negative 4x, but those don't add up to negative 5x. Okay, let's try something else. Maybe the 2x and the 3x do work, but it is the 4 and the 1. Here I'd get 3x. Here I would get negative 8x. Oh, there we go. 3x minus 8x is negative 5x. So a little bit of guess and check with numbers, a little bit of guess and check with order allows us to correctly factor any quadratic expression.